If your Tinkercad circuit is giving you an error, freezing, or not behaving the way you expect, don't worry. In this video, I'm going to walk you through the most common causes and show you exactly how to fix them step by step. This is one of the fastest ways to troubleshoot Tinkercad circuit problems, whether you're building with LEDs, resistors, an Arduino, a breadboard, or even motors and servos. And if this tutorial helps you out, go ahead and hit that like button and subscribe for more simple tech tutorials just like this. Let's get into it. The first thing you want to check is whether you have a short circuit. A short circuit usually happens when power is connected directly to ground without anything in between to control the flow of current. So look closely at your breadboard and wiring. Make sure no wire is connecting the positive rail directly to the negative rail. If that happens, Tinkercad can throw an error or the simulation may fail instantly. Also, check for components that are accidentally bridging the same vertical column on the breadboard. For example, if an LED or resistor is placed in a way that creates a direct zero resistance path, that can cause the circuit to break. A good habit is to zoom in and trace every connection one by one so you can see exactly where the current is going. Next, validate your component values. This is a big one because sometimes the circuit looks correct, but one wrong value can cause the whole simulation to fail. Start with your resistors. Make sure they are not set to 0 ohms because that can act like a direct wire and create a short. On the other hand, if the value is absurdly high, like 1 gigaohm, your circuit may not function properly either. If you're using an LED, check the polarity carefully. The anode, which is usually the bent or longer leg, depending on the component view, should go to the positive side. The cathode should go to the negative side. And for most standard LED circuits in Tinkercad, you should use a 220 ohm resistor to protect the LED and keep the simulation stable. If you skip the resistor or use the wrong one, Tinkercad can sometimes act like the virtual bulb is broken or overloaded. Now let's move on to the Arduino code, because a lot of Tinkercad circuit errors are actually code errors, not wiring errors. Open your code editor and look for any red highlighted lines. Those usually point to a syntax issue. Common problems include missing semicolons, unclosed braces, or brackets that don't match. Even one tiny typo can stop the simulation from running. If your circuit seems completely unresponsive, scan through the sketch line by line and make sure every opening bracket has a matching closing bracket. Also pay attention to your loops. If you have a loop or while statement running constantly without any delay, the simulation can freeze or become unstable, especially in the browser. Adding a small delay in the right place often solves the issue immediately. It gives the simulation time to process the code properly instead of trying to run everything at once. So if Tinkercad is hanging or lagging, check whether your code is missing a delay function. Another thing to verify is pin matching. This is easy to overlook. If your code says pin 13, but your wire is actually connected to pin 12, the circuit won't work the way you expect. Double check the exact pin number in your code and compare it to the physical connection on the Arduino board in Tinkercad. The same goes for input pins and output pins. A mismatch here can make it look like the circuit is broken when it's really just connected to the wrong port. If you're powering high-draw components like motors or multiple servos, don't rely on the Arduino pins alone. They are not designed to handle heavy loads. In that case, use an external power source like a 9-volt battery or the appropriate power setup for your circuit. Too much current demand can trigger errors or make the simulation fail because the components are drawing more power than the board can safely provide. If you've checked the wiring, the values, and the code, but the problem still isn't fixed, go into your browser settings and make sure hardware acceleration is turned on. Tinkercad circuits depend heavily on the browser's ability to render and run the simulation smoothly. If hardware acceleration is off, the circuit engine may lag, glitch, or not load correctly at all. Turning it on can make a surprising difference, and if you're still stuck, try opening Tinkercad in an incognito or private window. Sometimes browser extensions can interfere with how the simulation data loads. Ad blockers, script blockers, or other extensions may cause strange behavior that looks like a circuit error when really it's just a browser conflict. A private window is a quick way to test whether that's the issue. So to recap, the main things to check are short circuits, component values, LED polarity, resistor size, Arduino syntax, loop delays, correct pin mapping, power supply limits, hardware acceleration, and browser extensions. If you go through those steps one by one, you can usually fix a Tinkercad circuit error very quickly without guessing. If this video helped you troubleshoot your circuit, make sure to like the video and subscribe for more beginner-friendly tech tutorials. Thanks for watching, and I'll see you in the next one.